Hi friends, in this session we would study about the relation. In our general life, we have seen that the relations are always exist between or among more than two persons. If there is only one person, there would not be any relation. The same in the mathematics. If you see, there are two sets, minimum two sets are required for existence of a relation. So I explain you, let A and B be two sets, then a relation R from A to B is a subset of A cross B, where A cross B is the Cartesian product of the sets. Thus, R is a relation from A to B implies that R is subset or equal to A cross B. So this is the basic definition of the relation. Now, I would like to explain with an example how we get the relations in mathematics. This is our graph we have, this is our x-axis, this is our y-axis, this is our origin. Now we take a set A. The element of set A are 1, 2 and 3, and we are taking another set B in which the elements are 4 and 5. Now we plot the elements of set A on x-axis and elements of set B on y-axis. So we plot the element of set A on x-axis. So we plot these elements here: 1, 2, 3. We have the points here, the integers on x-axis we have, and on y-axis we also have the integers 1, 2, 3, 4, 5, 6, so on. So here we are plotting the elements of set B. Here we have to plot the element of set A. Now x is equal to 1, so I draw a line which would be parallel to y-axis because it goes through 1. So I draw a line. This is our x is equal to 1. Now we have to draw another line. X is equal to 2 and another line, x is equal to 3. So x is equal to 1, x is equal to 2, x is equal to 3. We have plotted along this x-axis, and all the lines it will pass through x is equal to 1 and pass through x is equal to 2 and pass through x is equal to 3, always be parallel to y-axis. Now we plot the line y is equal to 4 and y is equal to 5. So it would be like this. It will go through 4 on y-axis. This is the first line and this is the second line we have plotted. So in this way we have plotted the lines here. So now we take the intersecting points of these both the horizontal and vertical lines. So we see, take the horizontal points here. We got here 6 points, 6 intersecting points, and find out the coordinates of these points. This will mention, the set of these coordinates would mention the relation between A to B. So relation between A to B, A cross B means the relation between A to B. So we would write in this way, the coordinates of this point would be 1 4, because we always put the value of x coordinate first and the value of y coordinate later. So it is 1 4, it is 2 4, second one, this one is 2 4 because the x is 2 and y is 4 and this is 3 4. Similarly, we obtain these values 1 5, 2 5 and 3 5. 1 5, 2 5 and finally 3 5. So is the relation A to B, A cross B, it is the universal relation is being mentioned by A cross B. Now let us explain you the domain and range of a relation. So look at this, let R be a relation from a set A to set B, then the set of all first components or coordinates of the ordered pairs belonging to R is called the domain of R, while the set of all second components or coordinates of the ordered pairs in R is called the range of R. So look at this, the first component 1 2 3 is the first component, this would be the domain of this R. It means the set A is the domain of R, and the second components, the second coordinates 4 4 4 5 5, the 4 and 5 are the range of R. So we could write here domain is 1 2 3, which are the first component. You see the first components of the coordinates of the ordered pair, these are the ordered pair 1 4 2 4, 1 ordered, second ordered, this is the ordered pair we have, and the range is the second coordinates, the 4 and 5 we have. So these are the range. So these are the domain range of the relations. Now we have explained algebraically also, thus the domain R is equal to A such that AB is an ordered pair belongs to R, and the range B, which is the second element, such that AB belongs to R. So this is the algebraically or in the set builder form we could mention in this way, the domain and range. Now we see how many ordered pair would be there in a relation. If you see here in this first set, look at here in the set A, there are 3 elements we have, total number of elements are 3, there are 2 elements we have, so the ordered pair would be 3 into 2, it would be 6. So here you see the ordered pair 1 2 3 4 5 and 6, so there are 6 ordered pairs we have. So in this way we could find out the ordered number of ordered pairs, and we could easily find out the sub-relations of this A cross B, because we already know that in the set theory 2 power n is the number of subsets. But here if we assume that the number of element m in set A, number of element n in set B, so we get m into n ordered pair, so we get here 2 power m into n sub-relations of this A cross B relation, A to B. So in this way we could easily find out the sub-relations of this. So here the sub-relations would be 2 to the power 3 into 2, so which is 2 to the power 6, which is equal to 64 sub-relations would be here. Now we study about the inverse of relation. The inverse of relation, we see that it is the B cross A. In the relation we have seen that the A to B relation, A cross B, and B to A relation is the inverse of A to B. So here I explain you, let A be 2 sets and let R be a relation from set A to set B. Then the inverse of R, denoted by R inverse, is a relation from B to A and is defined by R inverse BA such that AB belongs to R. Clearly we think that AB belongs to R and B also belongs to R. So it's the same thing here. I explain you how we get the inverse of a relation. First I show you the graph. This is our graph we have, and this is our x-axis, this is our y-axis, this is our origin. I plot the integers on this x-axis: 1, 2, 3, 4, 5, 6, so on. Here also I plot on y-axis: 1, 2, 3, 4, 5, 6. So this we have plotted the integers on both the axes. Now we take the same example what we have taken there. So I am putting here a. We know that the element of a was there 1, 2, 3, and I am putting here b. The element of b were 4 and 5. So we have to find the b cross a relation. So see what happens here. First what we have to do, we have to plot the points. We have to take the points b on x-axis, because it's a b cross a, so b would be first on the first product of this, so we have to put on here. So it is b would be on x-axis and a would be on y-axis. Just a moment. A would be on y-axis. So we have b, 4 and 5, so we have to draw a line which is passing through 4, and another line which is passing through 5, which are parallel to y-axis. So I draw this line here. So it is 4, the line passing through 4. This is the axis equal to 4. Another line I am plotting here, axis equal to 5. Just a minute. The axis equal to 5. These 4 lines we have drawn here. Now for a is along y-axis, so we have to draw 1, 2, 3 lines, the passing through 1, passing through 2 and passing through 3. So I draw a line passing through, is the 1, passing through 2 and passing through 3. So these we have drawn here 3 lines. Now we see the intersecting points of these horizontal and vertical lines. There are 6 intersecting points. Again we have these 6 intersecting points we have got here. So the coordinates of this particular point would be 4, 1, it would be 5, 1, it would be 4, 2, 5, 2, 4, 3, 5, 3. So we get here 4, 1, 5, 1, 4, 2, 5, 2, 4, 3, 5, 3. So this is the b cross a. It is the relation between from b to a. So we see the domain of this what would be. I put down the domain. Domain are all the first element of this ordered pair. So the first element of this ordered pair 4 and 5 we have. So the domain is 4 and 5. And we see the range, the second element of this ordered pair. So 1, 2 and 3. So this is 1, 2, 3. So look at this both. If we compare both the sets, here you see the domain is 1, 2, 3. Here is the range is 1, 2, 3. Here the domain is 4, range is 4, 5, and here the range is 1, 2, 3. It interchange the axis. So this is the inverse of a relation. So in this way we could easily find out the inverse of a relation. Now the third thing I would like to tell you, a relation on a set. Now explain the relation on a set. It defines like that: let A be a non-void set, then a relation from A to itself, a subset of A cross A is called the relation on set A. So non-void set means it should not be a empty set. There should be some element in the set. So we could find out A cross A. The last time we have taken a set A, there are different elements. Set B, there is different elements over there. So here we say the relation on a set. On a set we have to find the relation. We have a set A here. Again we are taking the same example here. We have a set A which is 1, 2, 3. There are 3 elements in this set. So now we have to plot the relation on set A to A relation we have to find out here. We have to find out A to A relation, A cross A. So what we will do here, we will put A along x and by both axes. We will put A. So first I show you my graph. Our graph, this is our graph, this is our x-axis, this is our y-axis, and this is our origin. I plot the integers on the along x-axis: 1, 2, 3, 4, 5, 6, so on. Here also on y-axis: 1, 2, 3, 4, 5, 6, and so on. So now I plot x is equal to 1, x is equal to 2, x is equal to 3 here. So it is x is equal to 1, x is equal to 2, x is equal to 3. So I plot here. It is the x is equal to 1, x is equal to 2, x is equal to 3, x. So we have plotted here x is equal to 1, x is equal to 2, x is equal to 3 lines. Now we plot a line. Now we see that here A we are taking here also we are using A to A relations. So here also 1, 2, 3 we have to put. So we take here 1, 2, 3, x is equal to 1, x is equal to 2, x is equal to 3. So we have plotted these horizontal and vertical lines along x-axis and along y, the parallel to x-axis and parallel to y-axis. Now we see the intersecting points of these horizontal and vertical lines. So we see the intersecting points: 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are getting 9 points here, because we know already this thing that the 3 elements are in A and 3 and also in this A. So we get the 9 intersecting points, 9 ordered pair we will get here. So A cross A is equal to the coordinates of this point would be 1, 1, this point would be 2, 1, this is 3, 1, this point would be 1, 2, this is 2, 2, this is 3, 2, and this point would be 1, 3, 2, 3, and 3, 3. So we have to write here 1, 1, 2, 1, 3 1, 1 2, 2 2, 3 2, 1 3, 2 3, and finally 3 3. So 9 ordered pair we have got here. The domain and range of these relation would be same. The domain is 1 2 3 and the range is also 1 2 3 because it is A to A relation. So in this way we could easily find out the relations between two sets, so more than two sets you could also find out through this simple way. So in the next session we will study about the types of relations. There are different types of relations we will study in the